And we're live. Welcome to the 7th episode of the Hitchhiker's Guide to the Industrial Metaverse. Today it's the title Virtually Real, Robotics and Automation. And I'm super happy to have two wonderful guests, Timo Gessmann from SCHUNK and Cal Garin from Ready Robotics. So welcome everybody. Just happy to be back again from the summer vacation. Virtual commissioning and automation, it's one of the important layers of industrial metaverse and bringing in the reality and be able to build up, ramp up faster and get going in the factory. So I'm really happy to talk to you guys. And I'm Mike Wagner, CTO and co-founder of ipolog. And I've come into contact with virtual commissioning like when I was with Daimler, like 2005 or something. We already used SCHUNK grippers to build up things. So that was my first contact with SCHUNK. Maybe Timo, if you want to introduce yourself a little.
Yeah, great. Thank you, Michael. Yeah, hello, my name is Timo. I'm responsible at SCHUNK for the research and development. So I'm heading here the R&D department and acting as CTO. As you just mentioned, Michael, SCHUNK, we are in the automation business. So we are a manufacturing company producing and developing, for instance, grippers for robots, but also automation tools for machine industry, for machine tools. We also have clamping devices. So we have a lot of mechanical stuff, which we produce mostly here in Germany, but also we are worldwide active. So we are worldwide presence and sell our products to our customers. And so for us, we are engineers by heart. So we are coming from the mechanical engineering topics and from the mechanical, real life, physical stuff. But now over the last years, we have also to deal with more and more software things and virtual applications. And so both worlds can come together, the physical world and the digital world. And I think that's what we discussed today about how to bring both worlds together and how to give a value and a value add to our customers in order to speed up automation in all branches worldwide.
Great, thank you for being here, and also great to have a supplier already thinking on this digital twin area. So the other part of the world, basically here with Cal. You've come from the automation field, right? And if you'd like to introduce yourself as well, please.
Absolutely. So I'm Cal Garin. I'm the co-founder and chief innovation officer at Ready Robotics. And Ready is a company that specializes in building software for automation systems that is more user-friendly. Because what we're seeing in the automation space is there's a huge demand for products that make automation faster and easier. And that's because more and more companies are getting into automation, but the sort of capacity of the world supply of people who know how to deploy that automation is very limited and actually can't keep up, right? So factories are in this position where they know they need to automate because the labor shortage is a real thing for them. But the labor shortage of people who understand automation is also a thing. And so being able to make tools like things that allow you to control robots or control an entire robotic cell or an automation cell, even if it doesn't have a robot in it, those type of tools need to be more usable by everyday folks, just the people that are at the factories doing the work currently. Those are the people that we think can actually be deploying automation rather than bringing necessarily in people who are sort of specialized in that. Because as I said, there's not enough of those people, right? So that's why we're very interested in virtual commissioning and simulation and things like that, because it's just another enabling factor that allows someone to start to experience that easier to use technology earlier on in their automation journey, whether it's from a training perspective or a product selection perspective, as we'll talk about. That's really it. So that's really what we're focused on, is on the side of building tools that are usable and also tools that will work with any robotic system. So our software ForgeOS, which you saw briefly on the screen there, that is one piece of software that you can use, and you can work with a Yaskal robot or a Fanuc robot or an ABB robot. You don't have to have that specific skill set for that robotic system in-house. You can sort of be picky and choosy about what you want to actually deploy in your factory and make the decision based on which is the best piece of hardware or the best product, rather than, oh, do I have that guy who knows how to program Fanuc, so we better buy Fanuc, right? But if he leaves, now I'm in this position where I have to go find another person who knows Fanuc, et cetera, right? Like it's really trying to democratize not only the use of those systems and make that easier, but also make it so that you can pick and choose what works best for you. And then you have a software platform, sort of like Windows or Android, that sits on top of all of that hardware that provides the same experience no matter what the underlying hardware is.
And also, like to get going faster, right? To be able to just ramp up faster and get your factory going, because you don't have to learn different environments, right?
That's exactly right. Yeah.
Yeah. And I think you started off from your PhD, right? And got this Forge operating system out of it, right? And
yeah, exactly. So yeah, I was doing my PhD at Johns Hopkins University here in the U.S. And I was working with my co-founder, Ben Gibbs, who's the CEO of Ready. He was at Johns Hopkins as well. And we were playing around with this technology that I had been building for my PhD, focused really around making programming, the act of actually, adding points to a robot and making it move, and sort of abstracting that to the user a little bit, making that much easier. We ended up deploying it to just as sort of a proof of concept for my PhD work to a factory in Baltimore, Maryland. And it worked so well that they tried to buy it, and I couldn't sell it to them because I actually needed it to, because I didn't own any of it because it was Hopkins, right? But I also needed it to finish my stuff. So we're taking this thing apart, and the guys are still trying to use it because it was working so well. And so we saw, look, there's a commercial opportunity here. There's a utility of having a piece of software that sort of acts in the best interest of the user and makes the act of programming a robot easier. So we spun Ready Robotics out of Johns Hopkins University. We're a venture-backed startup. We have investors like a wide variety of VCs, as well as we have investments from Rockwell and NVIDIA, and all around the mission of that sort of goes back to that moment where that person was like, hey, it's working and I don't have to have a person standing here because the robot's doing it. Please leave it, right? It all comes back to that moment, and we've been able to scale that across, lots of customers and different use cases in the manufacturing space.
That's great, yeah. And how did you guys got together? Timo, I know that you've come from Bosch originally, right? To SCHUNK and.
Yeah, right. So originally I worked at Bosch. Right now, since 2019, I worked here at SCHUNK. And yeah, Cal and me, we are both active in the automation business for sure. And as mentioned, we're also very active here in Europe, but also we're active in the US, where Cal is located. And so in the past, we already had a lot of projects together. Maybe during that, more focus on physical things. But now, as time goes on, and as Cal mentioned, as there are coming up new requirements for automation to make things more easy. Since there's also, over the last years, you see there are not only industry robots, as Cal mentioned, like Fanuc, ABB, Yaskawa, but now there also is the rise of cobots. So the world is getting more and more flexible. You have more robots in the world, and those robots are not made for have a high volume business, but for low volume, high variety. And in the past, also for us at SCHUNK, we have a huge mechanical portfolio, more than 11,000 components.
Wow.
But now the applications gets more and more diverse, more and more customer-specific, user-specific applications. And by doing this, based on the mechanical topics, there are coming more and more software and data-driven topics. in order to make the solution more easy to use and more flexible. And by doing this, we looked for corporations, and so that's why we found SCHUNK and Ready Robotics to join forces together. Since I was also our motivation to work together to leverage the USPs of both companies and partners to make automation easy and democratize the automation. And it's only working if you bring together mechanical guys, software guys, different companies, and then make it happen. And so that's why we started the cooperation with SCHUNK and Ready Robotics. And yeah, we are enjoying it very, very much and looking forward to provide and develop new solutions for automation business.
It's exciting. And you have to be more early, right, in the development process, in the engineering, because we
Exactly.
Right.
Yeah. Go ahead, Timo.
Yeah, exactly. Since, as mentioned, so in the past, if you do automation solutions for the industry, normally at the very beginning, you know what the automation system has to do later on. So you have a standard, you have fixed requirements, and you know you have to produce one and the same product for millions of times. So low variety, high volume. But nowadays, as mentioned, if you go into the cobots, if you go into new branches like e-mobility, life science, logistics, you don't know at the very beginning what the robot, what automation system will have to do later on. So that means the robot system gets more and more intelligent, and it has to understand later on, after delivering, how to adapt on the solution. And so it's very important to do more front loading, to use the power of software and the power of simulation, in order to double check all of the variety which is later on be needed. And you cannot do it with mechanical solutions. You can only do it if you know by heart at the beginning what is later on the solution. But if you at the very beginning don't know, you have to start with simulation, and then there's a great chance of software that you can at the very beginning, by front loading, simulate a lot of millions of billions of options, right, in order to ensure that later the system which we deliver will always support the customer specific application.
Yeah, you have to aid your AI algorithms and have the system learn, right, with all the components.
Yeah, it's interesting. I think we actually have a link to an article that we've been working on, very similar to that point. And the reason is because, as Timo mentioned, right, there's a large number of people who are in the industry who sort of have been doing this for a while. And if a company is lucky enough to have that talent, then they know which product they need out of those 11,000 items in the SCHUNK catalog, right? They can just pick it out and be like, all right, we have a new project. I need this gripper. I need this work holding, and we're good to go, right? But we envision a future 10 years from now where those current people in automation are like 10% of the people who are deploying robots, which means the 90% now needs to be familiar immediately with SCHUNK's catalog. And so what we saw, being a longtime SCHUNK customer, is the opportunity to say, look, we can allow people to actually play around with these devices in simulation first, before they even start planning the rest of the automation system, right? To understand the capabilities, to understand the use cases under which those devices perform the best. SCHUNK has a lot of really compelling products, but some of them are very specific for specific applications. And if you don't know that specific application, it's hard to articulate the value of that specific thing. And right now, that's a customer journey where you're going to call somebody at SCHUNK and they're going to walk you through that. They have these really great centers where you can actually send them parts, and they will actually like build sort of a mock-up of manipulating the component that you want. And it's a lot of, and it's a really amazing service, but it's also something that it would be very difficult to scale if I said you're gonna have 10 times the amount of people that are wanting to, or 100 times the amount of people that are wanting to play around with your hardware before they buy, right? So this sort of try before you buy thing, we can enable that in simulation now, where you can go through a catalog of components and say, hey, I want to try this gripper in this situation with this robot. It's all in simulation. The control layer is done through our software. So you have that immediacy of like, it's very easy to just start using this robotic programming software. You could actually program out a whole task in simulation before you even decide which component you want to buy. When you then buy that component, you've already done a lot of the work, because with our software, you can take that program you wrote in simulation, you can transfer it onto the real robot and the real hardware too, right? So it's this idea that even during customer discovery, where they're deciding which product to buy, they're already starting to do the work of automating the actual task. So then when they get into the real situation where they're in the factory floor, where it's the most expensive, right, where you do not want downtime, where you want to have figured all of this stuff out beforehand, they have to spend very little time in the real world doing the actual work, because they've front loaded it, as Timo said, in simulation before buying. And I think that that's really sort of the sort of aha moment that we had together, was we can build a simulation tool that lets customers explore. We're even calling it the Automation Explorer. Lets them explore these products in situations where they actually can pick things up. There's real physics, because we're using NVIDIA Omniverse. So you can get sort of a realistic experience of how things are going to go, and you can find the products that you need. The other piece of that that's really important is it allows you to start to see the circumstances under which that device is going to perform the best, right? Grasping things is a fairly complicated practice, just because there's different materials involved, there's different forces involved. It depends on the part and the shape of the part, the shape of the fingers, all these sort of complexities. You can simulate first to know that, okay, for this shape and these finger geometry, I'm going to get a really solid grasp. It's not going to go anywhere. And you can validate that before going into the real world and finding out, oh, I needed to make this out of a different material, or it needs to be a different shape. All of that work can be done sort of empirically in simulation. Whereas with just like a CAD tool, you're going to get the geometry, but you're not going to know, oh, well, over a certain amount of force, it slips out, or I'm going to squeeze too hard and I'm going to damage the part, so we can't go that hard. Oh, all of that kind of stuff that you would learn like on the factory floor while you're deploying it, you can learn in simulation now first.
Yeah, you said the Automation Explorer. That's your like future product as well. I was asking myself, how do you like put 11,000 components into that? What's your like approach there to share all these elements?
Yeah, it's part of the magic a little bit there, but we've come up with a really great strategy to make it a scalable solution for SCHUNK, because they do have a very large catalog of components. And so it's really, there's sort of a whole engineering backend underneath that product to make it so that it's a very streamlined process for SCHUNK as a company, because ultimately what we want is we want it to be very transparent, right? We want something where a customer can just interact with it. Everything is there. And it works from a front end perspective, but also from a back end perspective. We want to make sure that SCHUNK's engineering team and their sales team, that their workflows aren't fundamentally changing, that it's just in general easier for them to get these products into customers' hands virtually, without having to reinvent the wheel about how they're, creating files or sharing content, things like that. So that's been a lot of what we focused on together, is not only making sure that a customer is going to get a good user experience out of the end, but that the SCHUNK team internally is has a tool that's pleasant to use and that fits into their existing workflow, so that it's as minimal of impact as possible while creating the maximum amount of value.
I guess OpenUSD could also play a role into that if you're working with Omniverse and Isaac Sim. You have also shared a little video.
That's exactly right. And in some of these videos, you can actually see some SCHUNK hardware already. You see one of our robots being controlled by Forge OS. This is all like on a desktop computer. That's where this is happening, right? So the idea is the user is sitting here with Forge OS and the Automation Explorer on their desktop. they can program it, and then, as you saw, you have a real robot working, you can transfer that program over to the real robot, right? But here you see a few of SCHUNK's many, products, and with the goal that, you can actually put those onto a real robot and pick up real objects, in simulation. But that's really the vision there, is making sure that customers have access to this stuff as early as possible.
And I mean, an important point is also that you can simulate like the environment physically correct, right? That your grippers and all these components interact also in a physically correct simulated environment, right? That might be some also.
Yeah, I mean, maybe Timo, you can talk to sort of the engineering work that goes into behind the sort of the scenes of like making sure that these grippers perform and grasp properly, and then I can talk about the sort of simulation side.
Yeah, exactly. So in order to ensure that the gripper is working properly, you have to consider a lot of different things like mechanical, or at least you're starting with the shape, that the shape is correct. Then you have mechanical features, you have electrical features. Then, of course, as Cal mentioned, also the forces, so mechanical forces and so on and so forth. So it's really hard in order to define based on application and to select the right component. So as Cal mentioned, of course, we have a lot of experts who are able to tell the customer for this application, that's the right product. But as mentioned, also as Cal mentioned, it's of course also hard to scale that up to new customers, especially to customers which are not experienced. And so we use the tool in order to help the customer to make it easy for him to start with automation. And also, of course, we have our sales guys that also have a tool in their hand which they can easily adapt to the customer-specific applications. Since also that's a nice thing. Every day there are coming new customer requests. So we opened worldwide, for instance, 9 co-labs, so collaboratories, where we invite new customers to our lab, and they bring their automation challenges. And every day there are coming complete new challenges. Mm-hmm. And so we use the tool also then to find in a very short time the right product and the right solution for the customer application. And so that's great to have this cooperation and to use, as mentioned again, to use the simulation capabilities to find a very good solution in a very short time.
Awesome. Time just flies. We're almost at the end of our time. Maybe just to give a glimpse into the future, you said it, Timo. You have your collaboration labs, and what are the next steps for you guys?
Yeah, for us, we have the collaboration lab. So and we are very expanding our automation business. So our vision is that every SCHUNK component which we provide, and those currently are most of them are mechanical components, that all of them will get software and embedded system inside, and that we are able to use the power of simulation to enable those mechanical things, to enable them with software and digital twins in order to speed up automation worldwide.
Great, thank you. And Kel, what's your take?
Definitely. Yeah. Like I said, we're looking towards that future where you have a huge amount of newcomers that are coming into the automation space, that are deploying technology, that are buying SCHUNK products. And just, it's about, getting them to the right solution as sort of expediently and in a frictionless way as possible. And so we're going to be piloting this product, the Automation Explorer that I talked about, probably early next year. And we're really excited to make that a scalable tool so that ultimately, SCHUNK can have an entire sort of virtual catalog of all their different components, along with a variety of different simulated environments, different manufacturing systems, situations from all the verticals that Timo discussed, right? Whether it's manufacturing or life sciences, so that they can see how those products perform in virtual, in a virtual environment before going out to the real world. And they can see it with the kind of fidelity that NVIDIA Omniverse provides, with realistic physics, with realistic contact forces, all the little last millimeter things that are the difference between a highly performing and valuable fast return on investment automation cell and something you have to constantly babysit that's a huge money sink, right? It always comes down to that last millimeter in terms of how these devices perform. So if we can figure that out very, very early on, especially as Timo mentioned, when we get into these high mix, low volume situations where things are changing constantly, being able to work on that change in simulation without encumbering the physical system on the factory floor, that's what I think you're really going to start seeing. And that's the, the future that I think we're building together.
And all these possibilities with generative AI coming up, I think that's also just possible if you have all your 11,000 components as digital twins, right, in your simulation environment. So
right. I mean, you could imagine very soon, almost scarily soon, a situation where you pick out your SCHUNK gripper and then you type out, I want a factory where I'm picking up a glass vial, and we just automatically generate the entire, environment, the vials, all of that stuff. We have the model that SCHUNK has provided for the gripper. It's controlled by Forge OS, and it's just a few minutes to generate that environment and start actually programming a robot to do that task. That's stuff that NVIDIA has started to show with the generative AI and building environments using generative AI. We're very plugged into that. So that's 100% where this is going.
That's great. That's awesome. Yeah. Looking forward to that. Exciting times. Yeah. We've got questions. If you guys also have questions, post them. One question was for Timo, the USD downloadable stuff.
Yeah, that's great. We are working on that. So thanks for the question. Of course, we are working on that. We are currently in collaboration with Cal developing those files and validating. And as soon as we have successfully validated, we'll provide the files for sure. Yes.
Yeah. And I would say anybody who's interested, reach out to either myself or Timo. We'll definitely be looking for sort of in the Q1 of next year. We'll be looking for beta testers. I'd love to have that conversation with people who want to start play around with this. That would be amazing.
Also, if you put in the metadata, that would be awesome. All these limits and that's everything can be put into USD. That's kind of nice.
Yeah, that's what's really nice about the format is it's so extensible and it captures all that sort of physicalized information. So yeah, absolutely, that's going to be there.
Is there a standard already for those kind of items? I'm not sure.
Not that I know of. I mean, I think that's why we've been gravitating towards sort of Omniverse and towards the USD standard, because most offline programming software sort of have their own way that they model components, and there's a little bit of interoperability there. But I think that's changing because people will use different products for different reasons, right? Like you might be using, for instance, Siemens Process Simulate to do a very complex simulation of your entire factory, but then you want to bring in Omniverse for the sort of specific physicalized, experimentation around a very specific process, right? All these tools can work together, whether it's Omniverse and Process Simulate or Visual Components or any of the other offline programming tools that are out there. Those will all work together. And what's nice is when you go and then want to program that robot and transfer that program to the real world, Forge is also interoperable with all of those, right? So you have this sort of common layer again to be able to pick the thing, do the simulation that you need, even if it exists in a larger system with another simulation product like Process Simulate. And then you can still have that nicety of like being able to program that out and get a head start on the factory floor when you're ready to deploy it.
Right. Any more questions? Time just flies like hell. So we're if there are any more questions, you can also like post them on LinkedIn, and we'll try to answer them then afterwards, I guess.
Perfect.
That's
a great comment. Yeah.
Nice.
That's great. Yeah. Feel free to reach out for more information for both of us. We're very excited to bring people along on this journey.
Great. So yeah, I'd say thanks a lot, Timo and Cal. I think it was a very interesting discussion, and I would love to have one more some time in the future, because we just could like barely cover the different topics, right? And Yeah, thank you all, everybody who helped bringing this episode together. Aaron and Bea and Michaela, also from in all these background people. Without you, it wouldn't be possible. And so yeah, we're working together to the next episodes. For this episode, thanks again, you both, for joining and
Thank you.
yeah,
Our pleasure. Thank you so much.